Ever wondered how our moon came into being? It's not as straightforward as you might think. Our celestial companion, the moon, didn't just spring into existence. No, its genesis is a story of violence and cosmic chaos, a narrative set in motion around 4.5 billion years ago. Picture the early solar system, a chaotic ballet of interstellar bodies, each seeking their place in the cosmic dance. Among them, our fledgling Earth and another planetary body, roughly the size of Mars. This body we've come to know as Theia. Theia's dance with Earth was a short one, as it careened into our planet with an unimaginable force. This wasn't a mere fender bender, but a cataclysmic event that sent massive amounts of debris hurtling into space. The aftermath of this colossal collision was a ring of molten rock and dust circling around our ravaged Earth. Over time, this debris began to coalesce, pulled together by their gravitational attraction. Piece by piece, a new celestial body began to take shape in the Earth's orbit. This is what we now know as our moon. This theory, known as the giant impact hypothesis, is currently the leading explanation for the moon's formation. It explains many of the moon's unique characteristics, such as its size in relation to Earth and its composition. The moon's makeup is strikingly similar to the Earth's outer layer, suggesting they were once part of the same body. It's an idea that also accounts for the moon's lack of iron, as Theia's iron core would have been absorbed by Earth during the impact. Yet, like any good scientific theory, the giant impact hypothesis is continually being refined and challenged as we gather more data from lunar missions and advanced computer simulations. It's a testament to our ever-evolving understanding of the cosmos and our place within it. So, the moon we see today is essentially a child of a catastrophic celestial event, a silent testament to the violent beginnings of our solar system, forever etched in the night sky. The moon's surface is far from being a plain, lifeless expanse. It's a record of cosmic history. Let's take a moment to imagine the moon's surface. Picture a world painted in shades of grey, punctuated by dark flat plains and lighter, rugged highland regions. These dark plains, known as Maria, are ancient basaltic lava flows, remnants of the moon's fiery past. The lighter highland regions are older, heavily cratered, and bear witness to the moon's tumultuous history. These craters are more than just scars. They're a testament to countless celestial impacts over billions of years. Some are so large they span hundreds of kilometers. Now imagine trying to walk on this surface. The ground beneath your feet is covered with a layer of loose, fragmented material known as regolith. Composed of crushed rock, dust, and soil, regolith is the result of relentless micrometeorite impacts pulverizing the lunar surface over eons. But the moon's surface isn't static. It experiences extreme temperature variations that are nothing short of dramatic. With no atmosphere to regulate the temperature, the lunar day can sizzle at around 127 degrees Celsius, 260 degrees Fahrenheit, hot enough to boil water. When night falls, the temperature plummets to a frigid negative 173 degrees Celsius, negative 280 degrees Fahrenheit. The moon's surface, in its stark beauty and extreme conditions, is a testament to the raw power of the universe. It's a world sculpted by volcanic fury, shaped by celestial bombardment. Each crater, each Maria, each grain of lunar regolith tells a tale of cosmic history that we're only just beginning to understand. The moon, our closest celestial neighbor, constantly reminds us of the violent and chaotic processes that have shaped not just our planet, but the entire solar system. As we continue to study and explore, each new discovery adds another piece to the puzzle, another chapter to the story. The moon's surface tells a tale of celestial bombardment and volcanic fury. The next time you gaze up at the moon, remember, you're not just looking at a celestial object, you're looking at a history book of the cosmos. Did you know the moon experiences quakes and once had volcanic activity? It's true. Just like our home planet, the moon isn't a static, dead world. It's dynamic and has a fascinating geological past. Let's start with moonquakes. Similar to earthquakes here on Earth, moonquakes are seismic events that shake the lunar surface. But they are generally less intense. Scientists have identified 4 different types of moonquakes. Some are caused by the gravitational interaction between Earth and the moon, while others are triggered by the cooling and contraction of the moon's interior. These moonquakes have been instrumental in helping scientists understand the moon's internal structure. Just like the Earth, the moon has a crust, a mantle, and a core, though they are substantially different from ours. The moonquakes have shed light on these layers, revealing that the moon's crust is thicker than we originally thought, and that its core is smaller and contains less iron. Now, let's talk about lunar volcanoes. Yes, you heard that right. The moon was once volcanically active. Evidence of this ancient volcanic activity can be seen in the form of lava tubes, volcanic domes, and hardened lava flows. Most of this activity occurred around 3 to 4 billion years ago, during a period known as the Late Heavy Bombardment, when the moon was bombarded by a high number of meteors. This volcanic activity has played a crucial role in shaping the moon's surface. The dark, flat plains we see on the moon, known as Maria, were formed by ancient volcanic eruptions. These eruptions also released gases that contributed to the moon's very thin atmosphere, or exosphere. These discoveries have not only helped us understand the moon's geological history, but also provided valuable insights into the early history of our own planet. Despite its serene appearance, the moon has a geologically active past. The Apollo missions were a monumental achievement, marking humanity's first steps on another celestial body. These historical voyages began in the late 1960s and spanned into the early 70s, with 6 successful crewed landings taking place. 12 astronauts, the first humans ever, set foot on the lunar surface, forever etching their names in the annals of human history. The Apollo program was not just about setting foot on the moon, it was a scientific endeavor aimed at understanding our closest celestial neighbor. The astronauts were not merely visitors, they were explorers, researchers, and collectors. They conducted experiments, gathered data, and most importantly, they brought back a treasure trove of lunar material. These lunar rocks and soil, weighing in at 842 pounds in total, have provided scientists with invaluable insights into the moon's composition and history. These samples are like time capsules, preserving a record of the moon's geological past and offering clues to understanding the processes that have shaped it. The lunar samples have revealed that the moon's surface is covered with regolith, a layer of loose, fragmented material composed of crushed rock, dust, and soil. This regolith is the result of billions of years of meteoroid impacts, creating a landscape of countless craters and rugged highlands. The rocks brought back by the Apollo astronauts have also confirmed that the moon was once volcanically active. Evidence of ancient volcanic eruptions can be seen in the form of dark flat plains known as Maria, which contrast sharply with the lighter, heavily cratered highland regions. Moreover, these lunar samples have helped us understand that the moon, like Earth, experiences seismic activity. These moonquakes, although generally less intense than earthquakes, provide further evidence of the moon's dynamic geological past. The Apollo missions not only landed us on the moon but also brought the moon to us. They provided us with a tangible piece of our nearest celestial neighbor, enabling us to unravel its mysteries and deepen our understanding of the universe we inhabit. Our understanding of the moon has been revolutionized by recent discoveries and technological advancements. One such groundbreaking revelation is the discovery of water ice at the moon's poles. These permanently shadowed regions, untouched by the sun's warmth, are cold enough for water to remain frozen, a fact that could drastically alter the course of future lunar missions and the possibility of establishing a lunar colony. In addition to water ice, it turns out that the moon isn't as atmosphereless as we once thought. Although extremely thin, the moon does possess a tenuous atmosphere, known as an exosphere. Composed mainly of helium, neon, hydrogen, and traces of other gases, this discovery opens up new dimensions in lunar studies and could potentially provide valuable insights into the processes that have shaped the moon's surface over billions of years. Adding to the moon's mystique are the enigmatic lunar swirls. These strange, bright patterns on the moon's surface, believed to be caused by magnetic fields and interactions with the solar wind, present yet another intriguing puzzle for scientists to solve. The role of lunar rovers in scientific exploration cannot be overstated. These robotic explorers have been instrumental in gathering and transmitting valuable data back to Earth, expanding our understanding of the moon's geology and environment. As technology continues to advance, future lunar rovers will be equipped with more sophisticated instruments, tasked with carrying out more complex missions. These discoveries not only fuel our curiosity, but also pave the way for future explorations. The presence of water ice could provide a vital resource for long-term lunar habitation, While the existence of a lunar atmosphere could offer valuable clues about the moon's past and its potential for supporting life. As we continue to unravel the moon's secrets, who knows what surprises our celestial neighbor still has in store for us? Our pursuit of knowledge about the moon is far from over. As we stand on the brink of a new era of lunar exploration, each discovery brings us one step closer to potentially establishing a human presence